21st, 1986, marked the 50th anniversary of the Garrett Corporation. Today, Garrett has products on, or provides service to, the majority of business, commercial, and military aircraft in the Western world. Garrett is an important aerospace company that continues making its mark on the history books. A company whose business was begun and built, literally, out of thin air. "50 years ago, the aircraft industry was in its infancy, much like space travel is today. In the early 30s, airplanes were made on the East Coast. In the late 30s, however, that business had shifted to the West Coast, where there was lots of space, nice weather, and a strong interest in this exciting new industry. But the thing that was missing in the West was a distributor for the special tooling required by the airplane manufacturers. John Clifford Garrett saw the opportunity created by this need. So on May 21st, 1936, Cliff Garrett founded Aircraft Tool and Supply Company in Los Angeles. He did what no one else was doing, and his company quickly became very successful. Today, that original company exists in the form of Garrett Industrial Supply and Garrett Air Supply, the basis for what has become one of the world's biggest and most respected aerospace companies. Cliff Garrett wasn't content just supplying and servicing tools and equipment to the aircraft manufacturers. Like many others of the day, he had a vision, a dream. He wanted to fly faster and higher, where the air was thinner. Of course, aircraft like this B-17 were already flying way up there. But crews had to wear this, an oxygen mask. Even with the mask, the physiological demands on the crew were tough.
Needing to supplement by using oxygen masks, it was always a problem. I remember once we were right on the bomb run, and my bombardier was leaning over the bomb site and got a burst of flak right up in the nose and blew a big hole in the plexiglass window. And he didn't realize it, but this piece of flak had gone right near his neck to the point that it cut his oxygen hose. And so he was still working on the bomb site, and he passed out. And my navigator thought sure as heck he'd gotten hit by that flak. But those were the problems. And when I think back on it today, we never had a cup of coffee. We wouldn't think of flying an airplane today without having some soft drinks, coffee, sandwiches. And we didn't carry anything. They never made up sandwiches for us. Nobody had a thermos. And we had a canteen we'd keep filled with water, but they would freeze.
Somehow, the safety and comfort of the Earth's low-altitude environment needed to be transferred to high-altitude flight. Late in 1939, with $5,000, Cliff formed a new company to search for a solution. A name was adopted for this new company. It was to be called Air Research Manufacturing Company. A young MIT graduate by the name of Walt Ramser was put in charge of engineering. Air Research's first product was an all-aluminum intercooler for the B-17. Cliff and Walt Ramser, working closely together, then developed and perfected a cabin pressure regulator. More than 3,000 were developed for the Boeing B-29, the first production aircraft to be pressurized. Throughout World War II, Garrett was the world's only source of cabin pressure regulators. Finally, Cliff's dream of comfortable high-altitude flight was realized. By the end of the war, Air Research had acquired years of experience to meet the demands and the comfort level of the booming new era of air travel. Then came the breakthrough that changed the world. The jet engine. But there was a problem. The cockpit of the Lockheed F-80 became an oven during flight. Neither the pilot nor the instruments could survive the seething temperatures. An integral refrigeration system was needed to keep the pilot from baking. Lockheed turned to Air Research, the company that had proven experience in building cabin pressure regulators for the B-29. Air Research accepted the challenge. The solution was a cooling turbine or refrigeration package. It marked the entry of Air Research into the turbo machinery field. Now, pressurizing and cooling a cockpit meant moving air around, heating it, cooling it, controlling it. Soon you begin to duct it. Add a valve here, an actuator there, and what you've got is an ECS. An environmental control system. A system like that used on the Lockheed Constellation. And that got us here, to the modern airliner. Today, at 35,000 feet, we relax in total comfort, even though the temperature outside is a minus 40 degrees, and the air is too thin to breathe. At the same time, Air Research was overcoming the environmental barriers to high-altitude flight. Another problem was emerging. It was out there, on the wing. The powerful new jet engines required a stronger kick to get them started. Instead of the electrical power, they needed the force of compressed air. In other words, a small jet engine was needed to start the big jet engines. And that's what Boeing came to talk to Air Research about in 1945. Boeing wanted an auxiliary airborne power plant. Up to that point in time, nobody had been able to build a workable gas turbine, or baby jet as they were called. There also weren't that many people around who even thought it could be done. About 6 months later, Air Research had an experimental unit officially called Project A, but unofficially referred to as the Black Box, for a lot of reasons. In the spring of 1946, the Black Box was put on the test stand, and the machine designed to do almost everything did nothing. It couldn't even drive itself. With the deadline running out on the Boeing contract, it was decided to voluntarily cancel the project. But the Black Box certainly was not a loss. Lessons learned formed the basis for many later projects. At the same time the Black Box was struggling on the test stand, the Navy began thinking about starting engines on a new seaplane. And in attempting to find a suitable auxiliary power plant for the huge P-5Y turboprop flying boat. Air Research was determined to develop an effective and efficient gas turbine, and based on its experience with the Black Box, it did. The Navy was willing to gamble on 2 experimental Air Research units. One was the F-80 cooling turbine, mated to the GTP-50, the spin-off of the Black Box. The combination formed the basis for air turbine starters. The second experimental unit evolved into the gas turbine compressor, 4344. It was the first truly successful small gas turbine and the predecessor of the auxiliary power units Garrett has been manufacturing ever since. Today, Garrett's 85 series auxiliary power units are utilized aboard aircraft such as the McDonnell Douglas MD-80, providing ground electrical power, air conditioning, and the power to start the aircraft's main engines. Over 25,000 of this single type of APU have been delivered by Garrett and are in service on commercial and military aircraft around the world. The growing APU business grew right into Arizona. During World War II, Air Research had operated a facility in Phoenix in response to the War Department's request to move essential war production away from the West Coast. With the end of the war came the end of the Phoenix facility. By 1951, the growing gas turbine business brought about a reopening of the Phoenix facility, named Air Research Manufacturing Company of Arizona. The post-war years were a booming time for both the country and the aviation industry. During this period, the idea of aviation changed from adventuresome to practical. Those years also saw Cliff Garrett's company change. Surplus aircraft were in abundance. The need for aircraft maintenance and modification increased dramatically. And so began Air Research Aviation Company, first in Los Angeles and later expanding to other locations throughout the U.S. In 1984, Air Research Aviation, along with some other Garrett services, became Garrett General Aviation Services Company. Garrett's products move around a lot. In the early 60s, a support center was opened in Raunheim, near Frankfurt, West Germany. Garrett GmbH provided a full range of services, including spares, overhaul, engineering, and training. Today, Garrett GmbH is headquarters for all Garrett customer support activities in Europe, Africa, and the Middle and Far East. In the 1950s, America was busy building, and the Caterpillar D9 cleared the way, thanks partly to the turbochargers built by the new Air Research Industrial Division. Garrett had applied gas turbine technology to the requirements for diesel turbocharging, with dramatic results. Since then, AID has turbocharged Bell helicopters, Cessna Skyknights, Oldsmobile turbo rocket V8s, natural gas industrial engines, and Nissan 300 Turbo ZXs, to name but a few. With the spectacular growth of AID came an increasing demand for castings, for compressors and scrolls. This demand led to the formal recognition of what for many years had been an Air Research foundry operation, but was now to be given the title Air Research Casting Company. Today's casting company employs advanced technology to successfully compete in world markets. In the mid-60s, we were involved in the war in Vietnam. The environment there proved to be hostile to just about everything. Clothing rotted, machinery rusted, and engines choked on sand and dust. Into this was thrust a new Garrett product, the T-76 turboprop, a propulsion engine that performed its job superbly. The T-76 powered the Rockwell OV-10A Bronco, a twin turboprop designed for light attack and forward air control missions. Bronco proved that Garrett could build tough, durable propulsion engines. The civilian counterpart to the T-76 the TPE 331 turboprop has exceeded 10,000 engines shipped. In 1963, the founder of the Garrett Corporation and its champion for 27 years died. Cliff Garrett believed in aviation and his company. He made ideas become businesses. He made Garrett part of aviation's vocabulary. In that same year, Garrett merged with the signal companies. But Cliff's momentum lived on. It was soon to create a revolution in business aviation. In the early 70s, a prototype turbofan engine was delivered to Gates Learjet. The engine was designed to provide business jets with increased range by using fuel more efficiently. The engine, the TFE 731 turbofan, was certified in 1972 and entered service on the Dassault Falcon 10. The timing was perfect. In 1973, the oil embargo hit. Fuel prices went through the roof. For aircraft using thousands of pounds of fuel, fuel economy became paramount. Virtually every business aircraft specified TFE 731s. Over 5,000 have been manufactured and shipped.
Garrett has a long history of coming up with the right solution, usually out of thin air. In fact, when you think about it, Garrett is in the business of making the most out of air, shaping it to Garrett's bidding, where and when desired. It happens deep in the heart of a gas turbine, as expanding, burning gases push past precisely designed blade shapes. It happens when control valves channel air through and around a modern jetliner. It happens here, in this small stack of laminates, as a stream of air moves back and forth. The movement of the stream provides control inputs, which can actuate the thrust reversers for the DC-10, or detect changes in the attitude of a projectile traveling at high speed. It's called fluidics, and it's a product of one of Garrett's newer divisions, pneumatic systems. In 1980, Air Research Manufacturing Company of Arizona was divided in two. One part became Garrett Turbine Engine Company, and the other, the Pneumatic Systems Division, located in Tempe, Arizona. Located over there is the Garrett Airlines Services Division, dedicated to fulfilling the needs of the world's scheduled airlines.
Electronics plays a major part in Garrett, as it does everywhere in the world today. Garrett Canada is a world leader in hybrid circuitry. Products range from personal locator beacons for downed aviators to electronic environmental control systems.
Air Research Electronic Systems Division manufactures sophisticated engine controls and air data computers in the shadow of the Catalina Mountains on the edge of Tucson, Arizona.
While Garrett has always been an aerospace company, not everything Garrett makes will fly. Propelling this M109 howitzer is a demonstrator GT601 vehicular gas turbine. The GT601, together with the AGT101 ceramic gas turbine, comprise a venture into new technologies and applications. Military vehicular applications has led Air Research Manufacturing Company into the area of nuclear, biological, and chemical protection. NBC warfare requires soldiers to be protected from these agents and still be able to fulfill their mission. That's the role of Air Research's NBC Protective Systems.
In 1979, Atlanta dedicated its MARTA Rapid Transit System. AMC's advanced DC electric propulsion motors and auxiliary equipment make the system move. Air Research Manufacturing Company's involvement in ground transportation is worldwide, involving both AC and DC electric systems and flywheel storage devices. The cutting edge today is new products, like the T-800 Army helicopter engine. The peripheral vision display for maximum performance aircraft. And the TFE 1042, our first augmented or afterburning engine. So that's Garrett. Thousands of products from divisions and companies located in the U.S. and throughout the world. Where it all comes together is here. The Boeing 767 is typical of the newest generation of commercial aircraft. Smart, economical, and comfortable. Garrett controls tell flaps when and how to deploy, leading edges to extend, thrust reversers to actuate. Garrett valves open and close as directed by inputs from Garrett temperature control systems. The GTCP 331 auxiliary power unit provides power for ground air conditioning for passenger and crew comfort, no matter what the outside environment. Peak hydraulic power needs are handled by the ATMP-70. This air turbine motor pump is also able to provide emergency hydraulic power in flight. Windows are kept clear by Garrett heat control units. And of course, the cabin pressurization is handled by Garrett equipment. If your schedule and destination are different than that of commercial airlines, the answer might be a new generation business aircraft. Here again, Garrett provides the systems to assure safety and comfort, and the power to propel passengers and aircraft over 9 miles high at over 500 miles per hour. Today, the people of Garrett can look up with pride and see their accomplishments written in the sky.